Section 1.6 Other types of equations and applications. Rational equations. First, we need to know how to solve the rational equations. Before that, we need to find the LCD, the least common denominator. And then we're gonna multiply the LCD for both sides. But keep in mind that the rational expression, the denominator cannot be equal to 0. So when you propose the solutions for which any denominator equals to 0 are excluded from the solution set. Let's look at the example. So we do have the rational equation. For the first term here, the denominator is equal to 2. So this is good. This is okay. And then the second term, since our denominator has the variable, so first thing we need to do, we're going to write it down. X plus 1 cannot be equal to 0. Okay? Because when x plus 1 equal to 0, this guy will be undefined. So write it down. X plus 1 cannot be equal to 0 means x cannot be equal to negative 1. And then the third terms here, the denominator, this is going to be equal to 1. So this is okay. Now, we're going to find the LCD for this equation. We have 2, x plus 1, and then the 1, right? So the LCD will be 2 times x plus 1. Okay, now we're going to multiply the LCD for both sides. And then we do have the parenthesis here, so we're going to distribute 1 by 1. You're going to multiply 2 times x plus 1 with this guy. And then 2 times x plus 1 for the second terms here. Okay, for the first term, the 2 and 2 you could cancel out. So you're left with x plus 1 times 2x minus 3. Second terms, x plus 1 you cancel out. So you have a 2 times 5x here. Okay, right? Now, we're gonna use the FOIL method. Distribute 1 by 1. So x times 2x, x times negative 3, 1 times 2x, 1 times negative 3. Distribute it. And this is gonna be 2 times 5x, which is gonna be the 10x. This guy, distribute 1 by 1. So check your work. Now we're gonna combine the 9 terms on each side. So we do have negative 3x plus 2x plus 10x. So you simplify it, you're gonna get 9x here. And then we're gonna subtract 2x squared for both sides. And also subtract the 2x and add 3 together. Okay, divided by 7. Okay, after you find your x, double check. Remember at the beginning, we wrote it down, x cannot be equal to negative 1, right? Did we get the negative 1 here? No, so this is good. So we're gonna write it down. X is gonna be equal to 3 over 7, okay? And the restriction, x not equal to negative 1 does not affect this result. Okay, now we're gonna check the work. We're gonna plug in x equal to 3 over 7. So do it 1 by 1 here. At the end, you should get 3 over 7 equal to 3 over 7. So this is a true statement. So we note our solution set is gonna be 3 over 7. Okay, one more example. So first, think about it. we do have a variable on the denominator. Okay, both of them is going to be x minus 5. So we're going to write it down. X minus 5 cannot be equal to 0. So means that x cannot be equal to 5. What is the LCD? That will be x minus 5 here. Okay, now we're going to multiply the LCD for both sides. Make sure you're going to distribute one by one. Try. Solve for your x. So the first term, we're going to cancel out x minus 5. We're left with the x. And the second one will be 5 times x minus 5. This one cancel out. I'm left with the 5 here. Okay, distribute the 5. Combine the 9 terms. So 6x. And this is going to be, we're going to add 25 for both sides. Divided by 6, you're going to get x equal to 5. Okay, remember at the beginning we say x cannot be equal to 5, right? Because when x equal to 5, when we plug it in, we're going to get undefined. If the only possible solution is 5, but we know that we do have the restriction on that, that means this is no solution. Okay, the solution set is going to be empty, means no solution. Okay, try this one. Okay, LCD, that will be x times x minus 3. Okay, this guy is just you distribute it. And then we have the restriction that x cannot be equal to 0 and x cannot be equal to 3. Okay, now we're gonna multiply the LCD for both sides. Distribute one by one. So you're gonna get this. Distribute for the x. Combine the 9 terms. Okay, factor out. You could use the x method. So you're gonna get x minus 2 times x minus 2. And x is gonna be equal to 2. Okay, we have the restriction that x cannot be equal to 0 or x cannot be equal to 3. But now we got like x equal to 2. So that's good. So my solution set will be x equal to 2. Word weight problems. If a job can be done in t units of time, okay, t represent the time, then the weight of job, the R, is 1 over t of the job per unit time. So we have the formula here. The weight of work equal to 1 over time. And then the amount of work completed, A. So this is the amount of the work, is found by multiplying the weight of work. The weight of work is going to be the R times the T here. So if you plug in the formula, you're going to see T times T, that's going to be equal to 1. 1 is talking about the whole job, okay, the one whole job here. And this formula is similar to the distance formula. D equal to the weight times the time here. Okay, let's look at the example. Solving a work weight problem. Lisa and Keith are working the lifts in their backyard. Working alone, Lisa can work the lifts in 5 hours, while Keith can work them in 4 hours. So Keith can do the job 1 hour faster than the Lisa. How long would it take them to work the lifts together? So if they're working together, for sure it's going to be less than 4 hours, right? So first, we're going to let X be the amount of time it would take them to work the lifts together. Okay, so Lisa do it by herself, it's going to be 5 hours. Keith do it by himself, it's going to be 4 hours. Now, we're going to let X be the time that Lisa and Keith do the jobs together. And then in 1 hour, Lisa can do 1/5 of the job by herself. Same idea for the Keith, it's going to be 1/4, right? In 1 hour, Keith can do the job 1/4 by himself. Now, let's get the table here. So we already let X be the amount of time when they work together, right? So the time here, we're going to put the X here. And then for the Lisa, in 1 hour, she can do 1/5 of the job by herself. For the Keith, it's going to be 1/4. Now we want to see part of the job that they complete. So remember this formula here. We have A equal to RT. This is amount of the work completed. So we're gonna multiply together R times T equal to the A. Same idea for the Keith. Okay, right? This is the part of the job for Lisa, part of the job for Keith. Okay, these two parts, we apply the formula A equal to R times T. And then think about it, part of the job by Lisa plus part of the job by Keith, that will be equal 1 whole job, okay? That will be equal to 1. So we're gonna add it up these two guys, that will be equal to 1. Okay, now let's solve these rational equations. First, what is the LCD? LCD, that will be equal to 20, right? And then we double check for the denominator. We don't have any variable, so this is good. Now, LCD equal to 20, we're gonna multiply the LCD for both sides. And then apply the distributive property. Distribute 1 by 1. You could simplify it. 20 times x/5 divided by 5 divided by 5. You're gonna get 4x here. And 20 divided by 4 here, divided by 4 here, I'm gonna get 5x here. So add it up, 4x plus 5x, which is gonna be the 9x. And then divided by 9 for both sides. Okay, so it will take Lisa and Keith 2 and 2/9 hours working together to work the lifts. Okay, that will be faster, right? Okay, power property. If P and Q are algebraic expressions, then every solution of the equation P equal to Q is also a solution of the equation P to the power of n equal to Q to the power of n for any positive integer n. So this is solving an equation involving the radical. Okay, let's do the example together. So we want to isolate the radical. Okay, we want to get out of the radical. First thing we need to do, isolate the radical. So we're gonna add the whole things for both sides. Once we isolate the radical, we can take square for both sides. Okay, because we want to get out of the radical, only way we could do is gonna be take square. Okay, so square and radical you could cancel out. Now we're gonna rewrite it to the standard form of the quadratic equation. Ax squared plus bx plus c equals 0. And then solve the quadratic equation. Factor out. You can use the x method. That will be 6 times 2, right? Zero factor property. X minus 6 equal to 0 or x plus 2 equal to 0. So we find it out, x equal to 6 and x equal to negative 2. Okay, when we're working on solving the equation containing a radical, when we have square root, the fourth root, when n is an even number, after we find it out what is your x, you have to check your work. Okay, this is part of your solution. Okay, make sure you check your work during the exam when you have a even root. So we have these two answers. We're gonna check it out. One is x equal to negative 2. Okay, plug it in. So you're gonna get negative 4 not equal to 0. This is a false statement. So we know that negative 2 is not a solution. We're gonna reject it. Now, we're gonna plug in x equal to 6. So that will be 24 plus 12, which is gonna be square root of 36. And then that's equal to 0. This is a true statement, right? So we only have a one solution, x equal to 6. Okay, one more time. When you solve the radical equation and the radical is an even number, you have to check your work. This is your part of the solution. Okay, make sure you did that on the chapter test. Okay, next example. This time we do have a 2 radical. We do have a 2 square root. So how can we solve this one? First, we're gonna isolate one radical. You're gonna move either one of them, the radical, to another side. So I'm gonna add square root of x plus 4 for both sides. Now we're gonna take square for both sides. Okay, let's do this one together. Okay, we have this guy, 3x plus 1 square equal to 1 plus square root x plus 4 square. Okay, right? So this one pretty good. You could simplify it. Get out the square root with the square. So you're left with 3x plus 1 on the left hand side. This guy, I want you guys apply the formula. Remember, you have the formula a plus b square equal to a square plus 2ab plus b square. Apply this formula. So this is going to be your a, this is going to be your b. Okay, you could write it like this. I need a square plus 2 times a times b plus b square. Okay, exactly the same formula here. So you could plug it in your a here, your b here, your b here. So you should have a 1, 1, and x plus 4 with the square root, and square root x plus 4. Okay, right? Simplify a little bit. So I have a 1 plus 2 square root x plus 4. And then this one, square root and the square cancel out. You're left with x plus 4 here. Okay, combine the like terms. 3x plus 1 equal to x plus 5 plus 2 square root x plus 4. Okay, and then we're gonna subtract x, subtract 5 for both sides. So I'm gonna get 2x minus 4 equal to 2 square root x plus 4. Okay, you could divided by 2 here, divided by 2 here. Try to simplify. So this one, if I write one more step, that will be 2x over 2 minus 4 over 2 equal to this guy, which is going to be x minus 2. Okay, now we're going to take square for both sides. This one, you also can use the formula. That's another formula. It's going to be minus a minus b squared equal to a squared minus 2ab plus b squared. Okay, so I'm gonna have an x squared minus 2ab plus b squared. Cancel out. I left with x plus 4. Okay, right? One more. X squared minus 4x plus 4 equal to x plus 4. And then subtract x, subtract 4. So I have an x squared minus 5x. I have an x squared minus 5x equal to 0. Okay, now factor out the x. Okay, don't divide it by x. Okay, we don't want to divide the variable. So factor out the x. We're gonna left with x minus 5 equal to 0. Okay, so 0 property. X equal to 0, x minus 5 equal to 0. So you do have a two solution here, x equal to 0 and x equal to 5. Okay, not done yet. Okay, remember when you solve the radical equation, when the root is a even number, like square root or 4 root or 6 root, you need to check your work. This is part of your credit. Please show it on the exam, okay? Okay, one more time. When you have a two radical, you want to isolate one of the radical. Take square. Once you get another radical, isolate the radical one more time, and then take square. Okay, our idea is try to isolate the radical and then take square to get out of it. Okay, once we get these two solutions, we are not done yet. We need to check our work. Okay, go back to here. Okay, this one I divided by 2 for both sides, but they didn't. Okay, they still keep the 2 here. That's okay though. And then they factor out the 4x and x minus 5. And then they have a x equal to 0, x equal to 5. Not done yet. Please check your work. So plug in x equal to 0 and x equal to 5. Try to check your work. Okay, I got the first solution, -1 not equal to 1, right? This is a false statement. So x cannot be equal to 0. This guy, I got 1 equal to 1, right? So this is a true statement. So x is equal to 5. We only have a one solution, x equal to 5. So make sure you double check your work. Okay, the cubed wood. So do the same thing. You're gonna isolate the cube wood for one side. And then this time, you're gonna, instead of take square, you're gonna take cube for both sides. Okay, take the cube for both sides. Cancel out. And then combine the nice terms. Subtract the x for both sides. Okay, use the x method. You solve for your quadratic equation. You're gonna get x equal to 3 over 5 and x equal to 2. Pretty straightforward, right? Okay, now check your work, plug it in. So you should get true statement for both of them. So we have the solution set is going to be 3 over 5 and 2. For the cubed root, usually we're going to get the true statement. When we have an odd number, most of the time you're going to get the correct answer like this. Okay, only even number, the square roots or the fourth root, you may get one of the four statement. Okay, let's try to do this example. X to the power of 3 over 2 equal to 216. So what we're gonna do, this is a 3 over 2, right? We want to get out of the exponents. So we're gonna multiply to the exponents of 2 over 3 for both sides. Okay, in this way, I could cancel out the 2, cancel out the 3. That will be only have the x in here. Okay? And then this guy, 216, I could rewrite it to the 6 to the power of 3. So 6 times 6 times 6, that will be equal to 216. And then we have the cube roots of this guy. And then the square, I keep it here. Now, the cube roots and the cube is going to be cancelled out. I left with the 6 square, which is going to be equal to 36. Since this is the square root, okay, when we have the square root, we have to check your work. Okay, we're gonna plug in back to the original equation. X equal to 36 here. Then this is gonna be square root of 36, which is gonna be 6. 6 times 6 times 6, which is gonna be 216. So this is good. Okay, another one. Same idea, we have the exponent 2 over 5 here. So we want to multiply for both sides for the exponent 5 over 2. Okay. And then this is going to be the square root. So we want to add plus minus here. The 4, we can rewrite it to 2 square. Okay, so 2 square to square cancel out with this 2. So that'll be 2 to the power of 5, which is going to be 32. And then we have a plus minus 32 here. And then we're going to subtract 7 for both sides. So we do have a 2 answer. One is 25, one is negative 39. Okay, try your work. Plug in back. I got the true statement for both sides. So the solution set is negative 39 and 25. Keep in mind that if when you rise each side to the power of 5 over 2, when you have an even number on the denominator, you need to add plus minus. Okay, just like when you take the square root for both sides, you need to add plus minus. Equation quadratic in form. An equation is stated to be quadratic in form if it can be written as a squared plus bu plus c. Okay, a cannot be equal to 0 and u is some algebraic expressions. Okay, just like this example, this is gonna be my u, okay, algebraic expressions. And then we have to the power of 1/2 minus 6, x minus 3 to the power of 1/4 plus x equals to 0. So we're gonna rewrite this one. we're gonna let u equal to x minus 3 to the power of 1 over 4. And then u square, when you take square for this guy, you're gonna have a 1 over 4 times 2, which is gonna be 1/2. That will be this one. So we're gonna rewrite this equation. That will be here u square minus 6u plus x equal to 0. And then we're gonna use the x method to solve it. So you're gonna get u minus 4 times u minus 2. Use the zero property. Okay, we find out u equal to 4, u equal to 2. But we are not done yet because u, this is what we make it up, right? The original variable should be x. So after you find out what is the u, you're gonna replace u equal to x minus 3 to the power of 1/4 for both sides here. And then we're gonna take to the power of 4 for both sides. So this means 4 times 4 times 4 times 4, which is gonna be 256. And then add 3. Same idea for this guy. X minus 3 to the power of 1 over 4 equal to 2. And then we're gonna take to the power of 4 for both sides. So that will be 16, add 3, that will be x equal to 19. Okay, double check your work, plug in back when x equal to 259. Okay, this is a square root of 256. You're gonna get the true statement, so this is a correct answer. And then another one. You should get the true statement as well. Okay. Okay, another one. Again, when we look at the equation here, we try to write it in the standard form. So we subtract 3 for both sides. And then look at the exponent. We have a -2, and this is going to be -1 here. Okay. And then we're going to let u equal to x to the power of -1. Same idea, we're going to take square for both sides. Okay, so your x to the power of -2, that will be u squared. And this guy, that will be the u here. Okay, factor out. Zero product property. Find out what is your u. Okay, once you find out what is the u, remember u is the variable that we make it up. We want to find out the x. So we're gonna replace x with, so we're gonna replace u with x to the power of -1. And this is gonna be 1 over, means you're gonna flip this fraction. Same idea for this guy. Flip this fraction, so that will be -3. Okay, double check your work. How you get out the negative exponent? You're gonna flip the fraction, right? Simplify it. You're gonna get true statement for both of them. So this is gonna be our solution set. That's it.